Okay, so today I had this idea for a way to generate fractals. I was doing some doodles instead of working, and I had this idea. So I made some code now that will start drawing some things, and it will just let me show you what the idea is. So let's actually first make it square. I think I go like that better. So here it is. So my idea is that you can define a base pattern, and for now we'll make it 2 by 2. So let's say we define a pattern like this. Remember it's 2 by 2, so we have here a black, white, black, black. That's kind of the pattern. And another way to look at this is that you have black, then you have the opposite of black, then you have black and black. So you can also say 1, 0 or 0, 1, depending on how you feel, 0, 1, 0, 0. So how does this become a fractal? Well, we can say that this 2 by 2 square in itself is kind of like a 0. Like it's mostly black, so let's say it's a 0. In general, we'll say that it corresponds to the pattern in the upper left. Then I can make a 2 by 2 pattern of these 2 by 2s. So that's a 4 by 4. And the upper right, if we look at the small pattern, then the upper right of the big pattern should be what's a 0. So let's draw it over here. Let me draw an outline actually. Maybe that will just make it more confusing. Let's try. So actually let me do something else. So here is the corners. So we're trying to make a, no, that's not right, it should be like this. We're trying to make a bigger version of this. So that means this 2 by 2 should be black, but we don't make it fully black. We make it black in the sense that this is defined as a black one. Okay, so now if we look at the small pattern, the one below the upper left should also be black, so it looks the same. The one to the right of that should also be black, so we make that the same. The one here is the opposite of black, so we make it the opposite pattern. This is the pattern, same pattern, but then we make it opposite, so we turn the black ones white and the white one black, so it actually looks like this. Then we can repeat that this way. Like that. And same thing here. And this one should be white. And so that means that this 4 by 4 should have white, black, white, white. So what's a white one? A white 2 by 2 is this guy. So it looks like this. Then should have a black one. What's a black 2 by 2? It's this guy. What's a white one? It's this. And another one is this. So now we kind of have a fractal where this guy is black. It's not fully black, but it's black in some sense. This guy is white in some sense, in the sense that it's the opposite of this one. This one is also black, this one is black. And if you look at the 4 by 4, the small square, then we have the same pattern. We have one that's black, one that's white in the sense of being opposite of the black one, and then a black and a black. So it all stems from the fact that we define kind of a pattern like this, and we say that is equivalent to just a black one. The white pattern follows, it's this guy. And then I just repeat it. You can repeat it from any level. So you can also imagine doing other things like this. It's probably a little bit boring. But then we have black, black. The one below it is white, so it's the opposite. The one over here is white, it's the opposite. One down there is the same. Then we can look at this guy. In the small pattern, this is the reference pattern. Below it, this one is black, so below it should be white. That means that we And remember, the white is just the opposite, so it actually has like this. So we should make it black and white. This one is black, and this one is white. So you see, this one is not so interesting, but this one looks quite interesting, I think. You can also make it more than not just square. Like you can imagine having a, let's say, a 4x3 pattern, maybe something like this, and then you can see what happens. Obviously, then we have to repeat this small pattern, this base pattern. We have to repeat it 4 times down, 3 times to the right, and so on. So, but anyway, let's try to write some code. So I want to just make a new file that will just contain all the code. So let's call it fractals.c, and let's put it here. This is just for organization, so it's not all in one file. I may change my mind on that. Actually, I think I already changed my mind on that. Let's do it like this. This is the UI code for clicking and stuff. So let's write the Fractal code here. So first let's have a data structure for storing patterns like this. And we're gonna call it, we're just gonna call it pattern, and it's gonna have a number of states. So we can call that the underlying pattern. So it will have a number of things in the X and things in the Y, and then it will also have a number of states. Now to begin with, this one will just be 2, but later on, probably not in this video, we can try to generalize it so we have 3, 4, whatever number of states. Okay, so now we want a way to make this pattern, kind of a pattern like this. So let's make this pattern that we had in the beginning as a test. So pattern is, I guess we can do this. It should not be 3x3, it should be 2x2. Delete that, and delete that. So we'll use 0 for black and 1 for white, and it will look like this. Let's see if it even runs. It does run. All right. Let's make a small function here that we call getValue, and it will take a pattern and an X and a Y, and it will do this. So now if I say printf pattern, no, not that. So let's printf and let's say value at 0, 1 is this guy, and then we'll just return for now. Value of 0, 1 is 0. So that's actually correct, because we want this. X is the horizontal and Y is the vertical. Great. So now we have a pattern. Now how do we draw it? So first we will do, let me comment out this drawing code here. So now we just have a blank background. So then we'll say draw fractal, and it's going to be this pattern, and it's going to be starting at, let's say 100 and 100. Let's call them actually start X is 100 start y is 100, and we'll call it width is 200 and height is 200, make it square. And how many levels do we want? Let's start with one level. So there we go. This is the thing we got. This is a pattern. This is an integer. Let's just substitute r for r int. And there we have it. So first, we will also need something like, let's say, state to color. Guess we'll also need that. We can do it here. Color, state to color is an array of two things, and it's just gonna be the opposite. Actually, state 0 is black and state 1 is white. And here we'll add that guy. Okay, so if levels is less than or equal to 1, what are we going to do? Else we will assert 0 and not implement it. Then we're going to need to include assert. Okay, and what are we going to do? So here we will just draw this basic pattern that we have specified here. So what does that mean? That means we will say square width is width divided by 2, square height is height divided by 2, and well, we don't know that. We need to look at the size of the pattern. So let's say it's actually pattern.width, because we need to have this many, and pattern.height. And then we're going to say for I equals I less than the width, we're going to go around in a grid, and there will be some kind of x, which is indeed start x plus I times square width, and there will be a y, which is start y plus j times square height. And let's find the state. Yeah, so we can, maybe we should call it get state instead. So we have the state here, we have the color, it's the color to state thing, and then we're simply going to say draw rectangle like that. So let's try to do that, and that didn't work because I forgot this guy, and apparently we don't have the mem set, which I was using for something. Oh, it's implicitly declared. Let's not do implicit declarations. Here it's complaining. I don't get. Okay, so there it is. Great. So let's make this one white again. Now we have the basic pattern. Amazing. Let's make it a bit wider. And maybe more close to the center. Okay, so now it's centered and looking super nice. Now, so that's if we're at the base level, but what if we are not? Then we have to do something. So we have to make a recursive call. That's how it kind of like, how it becomes a fractal. So we'll need this thing again. We'll need the width of each. And then we will actually need this loop, whoops, this loop again. But now instead of draw rectangle, what we're gonna do is call draw fractal. It's gonna be the same pattern. It's gonna start now at X and Y. It's gonna have these smaller widths, one less level, and state to color. Still not gonna work correctly because we haven't taken into account how the state changes. But let's try to call it with 2 levels. So you see, it will just draw the same again and again. But that's not quite what we want. So we need an extra parameter here. Which I'm going to call transform. So that's a little bit weird, but so we get the state, and then we want to apply the transform. And we have to make sure we stay within the number of states. So we mod by that. And now here we are gonna supply also the state as the transform, because it should be called with no transform. So yeah, whatever, let's keep that. Just to show what I mean, let's try it like this. So this white one is kind of like the inverse of the black one. So that's why over here we should invert all the colors. The way we set it up by we look up the color inside this array. So we can just cycle all the states forward by 1, and then taking the modulus with 2, and that's equivalent to inverting. But we should only do it if the state is 1. So I hope you will see now what I mean. Here when we look up the colors, we actually look up the opposite color, because the state of the right uppermost square is white, it's 1, so it shifts everything by 1. So actually I think that's it, and it should just work. Let's try to make a bunch of them. So that's it's very slow apparently. Let's not try to make 20. Let's try to make 3. That's not looking right. Okay, so when it's 2, it's correct. When it's 3, it's not correct. And why is that? So the top level will invert, then you go down. You need a white one here. So let's see what happens. So, right, because it's not using the existing transform. So we actually need to repeat this one, I think. Yeah. We need to use the transform that was already applied, not just the last one. So then we get white, 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 and black. Nice. Let's see how far we can push this. 5 is already okay. And let's say if is key released key U, then we will say levels plus plus, and if D is pressed instead, we will decrease the number of levels, and then this needs to be a variable out here. So now we can say like, okay, draw less, or draw more, and we can make this kind of pattern. So these triangles kind of like, let's do one more thing. Draw text and yeah, basically this. So now we can see, okay, so it's not that it takes a long time to run, it's just that when we go too far, the squares become too small. So that's pretty cool. So now I want one last thing. I want to have kind of like an editor. So let's say if the key is E, then editor open is toggled. And then we're gonna say if the editor is open, we'll do one thing, otherwise we will draw the fractal. And if it's not, let's just do this thing like not that, just right. So I can open the editor now just by pressing E. So if the editor is open, then I actually want to draw a small, I kind of want to keep this kind of irrationally. But yeah, so I want to keep this, and that's not what I wanted. And now how many squares do I want? I don't, well, let's see how that looks. So now it will just draw a bunch of squares, and it will keep this text, which we don't need. Okay, so basically now I can like make a pattern, and then I want to use that to draw this thing. So how do we do that? Let's have another one that is if is key released, and it's going to be S. So when we're in editing mode and we click S, press S, what will happen? We will first find a bounding box. Find a bounding box of toggled squares, and then make a pattern out of it. So let's try to see. Then I guess we have to loop over everything. Copilot was not really helping me. Then we have to say if toggles this thing, and then we check everything. So let me check this thing. There's a type called rectangle, I'm pretty sure. X and Y. Right, actually, so let's put this code like up here or something, and we'll return a rectangle that is toggle bounding box. And actually, it should be toggles. We'll take no arguments, and it will just find this bounding box. So there we go. We'll return a rectangle. We'll return this thing. So here we will instead say rectangle bounding box is get toggles, toggles bounding box, and it wait, what is it complaining about? Square size. Ah, we don't need these guys. Right, so it should be like this. And we cannot just return like that. What if I write rectangle here? Does it then understand? How about this? Okay, so now if I go into here and we do something and we click S, it something, but not tell us anything. So let's just print like the bounding box itself, or rather let's draw text format, and let's draw that text at 10, 10, 20, and it's black. So let's try that. Nothing happens. Nothing happens because it's only drawing it once, and then on the next next run through it will just overwrite it. So how do we do that? Let's not think about that right now. Let's just print F. But then I think we cannot see it right away. Maybe unless we do this. Okay, so that seems to be working. And another thing we might want to do is just have this little check that anything is on, and we'll say if not any on, we return 0, a 0 rectangle. so that if we go back here, we run it, and now it will just return 0, 0 instead of something weird that it was doing before. How does this look? Alright, so that looks correct. So now we have the bounding box. So then we can make a pattern. So let's say pattern equals something. Or rather, we'll reuse this variable that we have made up here. So we'll say new width is bounding box.width, new height is bounding box.height, and if new width is not equal to pattern.width, or new height is not equal to pattern.height, we'll free the old pattern, we'll make a new pattern with all zeros, and then we will assign here. Then we'll say for and actually it should be for j first. Not that it really matters, but just to keep it like memory local. Okay, so we need to find the index into the toggles. So it is something like this. X is equal to the starting point of the bounding box plus how far we are. Y is the same. The index is actually this. This is actually this, right? So this is actually correct, with one exception. In the toggles, the black squares are indicated by 1 and the white are by 0, so we actually want to invert that. So now when we run this, we should actually have it working. Right. That was easy. So let's go in here in the editor. So now let's try this guy. Then we're gonna press S for save. We're gonna close the editor, and now we have a new pattern. Let's go back. Let's do this thing. S for save, close the editor, we're back to the old pattern. Amazing. So we can also try this. So let's save, and it segfaulted. So that is great. That's very, very great. So I wonder why it's segfaulted. Let's try this thing. So we'll make a 3 by 3, we'll save, and it complained about that. How about we run it over here? No, wait a second. Let's comment all this out. Let's run it. So what happens when we make a 3 by 3? It looks fine here. Still there's a kind of a segfault probably here. So let's remove that. So try again. Okay, no segfault. Very nice. Right, so, no, sorry, that one we remove. These guys, we don't comment. So it's this free here. That's ultimately the same problem as down here. So let's add it back and fix the real problem, which is that we have this kind of like array here. So let's make a pattern which is some 4x4 and pattern 1 is 1. And then here we can just delete that and type pattern. And let's see if that works, doesn't work. Right, because, so maybe we should call it data. Now, 3x3, we save it, it works, we close it, it does something. That looks very weird, but I mean, it's doing something. So we save, we close. Let's step down the number of levels a bit. So, and it looks like it's even doing the correct thing. So that's pretty cool. Pretty cool. Now, just for the sake of making things look good, that was not what I wanted. So 100 and 100. It should be 150 maybe. I'm completely losing my mind right now. Okay, so let's change that to 100 and then this should be 600. Right, there we go. Uh-oh. Managed to crash it again. So apparently very big boxes doesn't like. All right, I think that's it for this video. So I will see you in the next one. Bye bye.